Hi folks, we're going to take a look at another example of performing multiple operations on a transformed function. Okay, so here again the function is given explicitly, so our first step is to determine what we're going to compare it to. In other words, what's the parent function that we're transforming. So here, because I see the x in the denominator, we're going to be using a parent function of y equals 1 over x. Okay, so next thing is to identify the transformations. Okay, so let's just write it in a slightly different way so we can more easily identify what the transformations are. Okay, so first thing here is I see this 2 in the numerator. Now normally we have 1 over x, so I'm going to rewrite the 2 outside, and it's going to be multiplying some fraction with 1 over, okay, a denominator. Now here my input is that value in the denominator. Here the denominator I have negative x plus 2, so that's going to become the input into my function. But of course we know that the input has to always be in factored form. Okay, so here there is a coefficient in front of the x that's different from 1. We have negative 1, so we have to factor out that negative 1. So when we do that, we're left with x, and then this becomes 2 divided by minus 1 minus 2. Okay, and then of course we've got the plus 2 on the outside. Okay, so if we did want to write this in function notation, so if we called our parent function f at x equals 1 over x, okay, this would be 2 times my function here, but with an input of negative x minus 2, and then plus 2. So this would represent the same function, okay, as this one here. Okay, now let's go to actually doing the transformation. So for our parent function 1 over x, we've chosen 4 basic points. Okay, so we use 1, 1. Okay, then we'll use 2, 1 half. Then we'll use negative 1, negative 1, and then negative 2, negative 1 half. Okay, and now let's perform our transformations. So now we're going to our transform function, and again I'm going to perform this all in one step now that we've established how each of these numbers affects the parent function. Okay, so when we think about the x values, what's happening with the x values? Well, here we have the negative in front, so that means we're dividing our numbers by negative 1. Okay, and then this x minus 2 tells us that we're going to be moving to the right by 2 units, so we'll be adding 2. Okay, so here we've got negative 1, okay, and then plus 2. And then for the y's, what's going on with the y's? Well, here we're multiplying the y values by 2, and then we're adding 2. So 2 times 1, and then plus 2. Okay, so in the end, we end up with the point. So this is negative 1 plus 2 is 1, and here we've got 2 plus 2 is 4. Okay, so the point 1, 1 got transformed to the point 1, 4. Okay, let's take a look now at the next one here. So again, this is going to be negative 2 plus 2, and then for the y values, it's going to be 2 times 1 half, 2 times the y value, plus 2. Okay, so that becomes a point. Well, negative 2 plus 2 is 0, and then 2 times a half is 1, plus 2 is 3. Okay, and let's keep going here. So here we have negative 1, so 1, and then plus 2. Okay, and then here we have 2 times negative 1, okay, plus 2. So this becomes a point. Well, 1 plus 2 is 3. Okay, and then negative 2 plus 2 is 0. Okay, and the last one here. So again, negative 2 gives us positive 2, and then plus 2. And then for the y's, we've got 2 times negative 1 half plus 2. Okay, so here 2 plus 2 is 4, and then 2 times negative a half, negative 1 plus 2 is 3. Negative 1 plus 2 is positive 1. Okay, so there you have it. These are our transform points. So now we take a look at our values to try to determine what our where our axes should go. So I see that the x values go from 0 to 4. Okay, so I'll put my y-axis a little towards the left, and my y values also go from 0 to 4. So I'll put my x-axis a little lower also. Okay, so let's go ahead and do that. So let's draw our x-axis here, and here we'll draw our y-axis. Okay, and because our numbers are relatively small, I can just go up by 1 unit at a time. Okay, use 1 unit for each box. Okay, so now we put our points on. So this, remember, 1, 1, and 2, 1/2 will be part of one branch of our function. Okay, and then these two will be part of the second branch. Okay, so let's start with 1, 4. So 1, 1, 2, 3, 4. Okay, and then here 0, 3, 0, 3. Okay, and then here we have 1, 2, 3, 0, and we've got 4, 1, 4, and 1. Now, since this is a reciprocal function, we know that the reciprocal function will have asymptotes. Okay, now the only thing that's going to change the location of the asymptotes will be the horizontal or vertical shifts. Okay, so let's take a look at how those asymptotes would change. So since I'm moving 2 units to the right, since the whole function eventually will move 2 units to the right, it means that my asymptote will move 2 units to the right. So instead of having an asymptote of x equals 0, I'm going to have this vertical asymptote of x equals 2. Okay, so I'll draw a dotted line here to represent my asymptote. Okay, and let's see what's happening to the horizontal asymptote, which is normally y equals 0, but since the whole function is being moved up by 2 units, the new horizontal asymptote is going to be y equals 2. So I'll just use a dotted line again to represent the asymptote. Okay, and now I can draw my function. Okay, so I know it's going to be going downwards like this. Okay, and eventually it will approach the other asymptote on the other side. Okay, and then here, okay, probably easier to turn it upside down, but I'll see if I can do a decent job. Okay, and then I'll cross that point and eventually approach the horizontal asymptote. Okay, and this is what my transform function looks like. Now, if in the question I asked for the new asymptotes, okay, well, here we have the horizontal asymptote, so HA. Well, that now is just equal to y equals 2. And if we look for our vertical asymptote, here we see it occurs at x equals 2. So again, also if you're being asked for an asymptote, remember these are lines, so you're expecting equations of lines. Okay, one thing you might want to work on here that I'll leave for you to do is to indicate what the new domain and range will be for the transform function, because here we see the domain and range will not be the same as for the parent function. Okay, so again, just to recap, when the function is given explicitly, step number 1, identify the parent function. Step number 2, rewrite it in the proper form so that you can identify the transformations. In particular, make sure the input is in factored form. And then from there, you take your basic points for your parent function and transform them one by one. Okay, that's it for this one.